Question number 19, paper 1. This question is based on angular momentum conservation. But how will you come to know whether the question is really based on angular momentum conservation or not? See, it's so simple. You are given a platform. The circular platform is given. You have given the mass of the platform, radius of the platform. This is the radius of the platform, and R is given 0.5 meter. You have also given mass. Mass of platform is 0.45 kg. On this platform, according to examiner, on this platform, two balls are given, like these are the two balls, and ball mass is also given, and ball mass is MB is equals to 0.05 kg. It is also given at what distance from the center these balls are placed. This distance is a small r, and a small r is given 0.25 meter. These all things are given in the questions. These are the given conditions, given situation in the questions. Now what the questions say? Questions say that you have a gun actually. These are not a ball actually. This is a gun. And from gun actually balls are coming out. See, the gun is placed here, and this gun will actually emit one ball in this direction. And similarly, there's another gun which also, throw a ball in this direction. And the velocity of these two balls is same, in fact, in magnitude, but in direction it is different. It is 9, and it is also 9. So velocity of ball, if you say VB, is 9. In this direction, another ball has velocity in this direction. When somebody throw, it's a Newton third law, when somebody throw from here, like some gun is throwing some velocity in this direction, due to recoil factor or due to recoil reason, some force will act on this direction. This is the force acting on the platform. And similarly, when this gun is firing a ball in this direction, due to recoil, due to Newton's third law also, we can say certain force will act on this direction. Now, because of these two force, it is 100% sure, because of these two force, this platform start rotating. So platform will get certain angular velocity because of these two force. If you consider the whole system, in system if you consider platform, if you consider gun and all the balls, you will find the equal and opposite force will act on the ball also, because ball is thrown like this. Due to third law, whenever two bodies interact with each other, equal and opposite force act on each other. Similarly, this force is acting as a recoil force, but what is the real force? It is a reaction force. What is the real force? Real force by acting on the ball in this direction, right? So, this is F, this may be F dash, F dash. We don't know whether the same force is acting or different force is acting, but forces are acting. Now, if you see the complete system, you will find equal and opposite forces acting at one point will give torque for the all point in the world. Similarly, these two forces are equal and opposite. Net force is 0, as well as the torque acting on any point in the system in the world. Net torque on the system about any point is 0. But this point is fixed. As it is fixed point, one external force must be acting here. Otherwise, how will this platform will remain stationary here? There must be some external force. But this external force does not provide any torque about this center, because this force is passing through the center. So we can say platform will rotate, balls are thrown, then platform will rotate, and net torque about this point of the whole system, net torque on the whole system about this point is 0. Therefore we can say angular momentum in this question of the whole system remain conserved, and angular momentum about this point is conserved. Now how will you calculate angular momentum? So we will use angular momentum conservation. Angular momentum conservation. Initial angular momentum is equals to final angular momentum. What is initial angular momentum? Initial angular momentum is 0, because everything was at rest. So there was no angular momentum. But once this ball has gone here and here, we can use angular momentum formula MVR for the ball. So MVR, M ball, V B ball, and they are at distance small r from the center, so the angular momentum is mvbr. But there are two balls and angular momentum of both the ball are in the same direction, so into 2. Now this platform is also rotating, it start rotating when this ball has gone, and this is rotating like this, is in opposite direction. So angular momentum of the platform is in opposite direction. So what is it? It is I omega. From this equation, you can calculate omega. Omega will be mb vb into r into 2 upon I. And what is I? Where I is equals to mass of platform into radius of platform square by 2. We know the value of mb, we know the value of vb, this is v small b, it's not a big B. So we know mb, we know vb, we know small r, we know mp, we know capital R, we know everything. Everything is given in the question. Now if you put all these things here, you will get I, and then finally you will get omega, and your omega will actually comes equals to 4 radian per second. So this is your answer. You have to solve this equation. That's all. Thank you.